Okay, in this lesson we're going to simplify, which traditionally was called reduced fractions, to lowest terms. Now, doing this, you can do it a variety of ways. You can use prime factorization. This is the longer but surer way to do it. Let's suppose that we have the fraction 120 over 250, and you're asked to simplify it to reduce it to lowest terms. Now, I want to do it with prime factorization. This may not be the way that you will choose, but I want to demonstrate this. Let's take 120. Prime numbers. Well, you can factor any way you want, and you know that this is 12 times 10. But those are not prime numbers. So the 10 is 2 times 5, and those are primes. The 6, the 12, it could be 2 times 6, and that's a prime, and 6 is 2 times 3, and those are primes. That's not the only way to factor that, but no matter how you go about it, you're going to have 2 times 2 times 2 times 3 times 5. I went 2, 2, 2, 3, 5. Now let's take 250. I see 10 times 25, and 10 is 2 times 5, so I've got those primes, and 25 is 5 times 5, and those are primes. So here I have 2 times 5 times 5 times 5. When I divide out common factors, because 2 over 2 is equal to 1, and 5 over 5 is equal to 1, and it didn't matter which of those 5s I got, and it didn't matter which of those 2s I got, I'm left with 2 times 2 times 3 over 5 times 5, which is 2 times 2 is 4, times 3 is 12, 5 times 5 is 25, and there is the fraction in lowest terms. Now, I went through this very formal way of finding the prime factorizations. How could I have done it another way? Well, I could have looked at 120 and 250 and said, those are both divisible by 10. So if I divide by 10, because my divisibility rules say that if it ends in a 0, it's divisible by 10, it will go into the top 12 times and in the bottom 25 times. There's no longer a common factor, and I got to the same answer much quicker. But what if you didn't think about this 10? The prime factorization method will always work, but it may be the long way. So let's just look at some problems. Some of them I'm going to use prime factorization, and some of them I'm not. Problem number 1. I have 3 over 12. I'm looking for a common factor to divide out. I know that 3 goes into itself, and I also know that 3 goes into 12. So if I divide both the top and the bottom by 3, I get a 1, and 12 divided by 3 is 4. So that is same as 1/4. If I had done prime factorizations, it would have worked the same way. Let's look at 4 over 10. Now 4 is not a common factor. 4 does not go into 10 evenly, but they are both even. So I know that I can divide both of them by 2. I use my divisibility ideas. So 4 divided by 2 is 2, and 10 divided by 2 is 5. That fraction is simplified, reduced to lowest terms. Right? 2 over 6. Well, they are both divisible by 2. Well, that got an extra dot in it. And divided by 2. 2 goes into 2 once. 2 goes into 6 3 times. So that is 1/3. Now the next one is an improper fraction. It is top heavy. And 9 goes into 36 evenly. When you see that, you could do the division by 9. That will get you 4 over 1. We do not leave denominators of 1. 1 goes into 4 4 times, so that would become the whole value. You didn't even have to reduce if you had just said 9 goes into 36 4 times. Right? Can you think of a common factor between 30 and 35? Well, this one ends in a 0, this one ends in a 5, so my divisibility rules say that I should be able to divide by 5. It goes into 36 times, it goes into 35 7 times. All right, 2836. Just for the practice, I'm going to use prime factors on this one. All right, I think of 7 times 4. 7 is a prime, but 4 is not. It's 2 times 2. Those are primes. So the numerator is 2 times 2 times 7. 36. I'm thinking 6 times 6. Those are not primes. That's 2 times 3. That's again 2 times 3. So it is 2 times 2 times 3 times 3. All right, my common factors. 2's and 2's. That leaves me with 7 over 3 times 3 is 9. I could have gotten there without doing prime factors if I had recognized that 4 was a common factor. 4 goes into 28 7 times and 4 goes into 36 9 times. All right, let's look at number 7. Can you think of something that goes into both? Now 6 does not go into 15 evenly, but what will go into both of them? How about 3? 15 divided by 3 is 5, and 6 divided by 3 is 2. Things like this are done so much more quickly if you know the multiplication facts, so that you know that 15 is the result of 3 times 5, and you know that 6 is the result of 3 times 2. The other option was the prime factorization. Let's see, this is 3 times 5, and those are primes. And this is 2 times 3, and those are primes. So it would have been 15 is the same as 3 times 5. 6 is the same as 2 times 3. Those divide out, and I'm left with 5 over 2, and I leave it improper. Okay? How are we going to do this one? Well, we could do prime factors. We can do just factors, common factors. They're both even. So suppose we divide both the top and the bottom by 2. You can always whittle it down. 16 divided by 2 is 8. 32 divided by 2 is 16. They're still both even. Let's divide by 2 again. That gives me 4. 16 divided by 2 is 8. All right, they're still both even. In fact, now I see that 4 will go into both of them. So if I divide by 4, that'll give me a 1, and 8 divided by 4 is 2. This is the fraction in simplest terms. You might have noticed, without doing a 2 and a 2 and a 4, you might have said, yes, 16 is the common factor. 16 goes into 16 once, 16 goes into 32 2 times. I could have done prime factorizations. I'm not going to do it, but I'll just show you. With prime factorizations, the top is 2 times 2 times 2 times 2. The bottom has 2, 2, 2, 2, 2. And you would see that if you did the prime factorizations. Divide out, divide out, divide out, divide out. That leaves a 1 on top, 1 over 2. Excuse me. All right, moving on to the next one. 350 divided by over 50. This is an improper fraction. Does it go in evenly? Well, 5 goes into, first of all, shortcut. When you're reducing and you have trailing zeros, you can mark them out. That was equivalent to dividing by 10. So now I have 35 over 5. And sure enough, 5 goes in there 7 times. It might be called 7 over 1, but ultimately must be called just 7. Last one, 13 over 26. Well, 13 is a prime number. It is 13 times 1. So I can't do anything with the top as far as factors. Now the bottom, 26, is even. It's divisible by 2. 2 goes into 26 13 times. Ah, those are primes. 2 times 13. There's my common factor of 13, so I end up with 1 over 2. So when I divide those out, there's always little ones left over, even if I forget to write them down. If a denominator is 1, we don't leave it. We call it 7. If a numerator is 1, it's critically important that you write it. So don't forget that. All right, practice simplifying your fractions.